Hello folks, so in this video I want to do another example, well maybe not another, but the first example like this of solving a trig equation, um, but I'll go through the recipe, so to speak, one step at a time and try to make it super duper clear. Okay, so this is the first tutorial since whatever, 2021 or whenever we did this during distance learning. Okay, so the equation that I found was this one. Sine of 2 theta times sine of theta is equal to cosine of theta. Okay, so let's go through steps one at a time. So step number one is I want to rewrite this thing, right? So the thing that makes it problematic so far is that I have sine and cosines. That's step one. I would prefer if they were all sine. It would make my life a little bit easier. And also, my arguments are different. So I have sine of 2 theta, but I also have sine of just 1 theta. So that will also make my life a little bit more complicated. So let's think. There's a number of ways I can go about this. In this specific, and again, I'm not the best at just saying like always do look for this first or always look for that first. And I don't know if there even is a way that is always going to be the quote unquote best way. But here's how I would do it in this example. Sine of 2 theta, I think that's one of the easier ones to remember, one of the easier identities to remember. So this is a double angle formula, sine of 2 theta, and we can rewrite that as just 2 times sine of theta cosine of theta. All right, so 2 times sine of the angle being doubled, which in this case is just theta, times cosine of, again, that angle that's being doubled. And then I have times sine of theta equals cosine of theta. We'll clean up the left side, and this is going to look like this: 2 sine squared of theta times cosine of theta equals cosine of theta. I'm trying to be really clear this time around of like saying cosine of theta, sine of theta, because I'm seeing a lot of you guys actually are leaving it out. And it gets really important, especially when you are, well, one is just mathematically incorrect to just say cosine and then not have something attached to it. Because remember, cosine is like an operation. So I can't just have, or like logarithms, right? I can't just say log blank because I'm taking the log of something. You're taking the cosine of something. So it needs to have something attached to it. Okay. And then also, if you don't put something there, you might forget, wait, is it supposed to be sine of 2 theta or just sine of 1 theta? And then you might easily forget. Okay, so please write down the thetas. Okay, tangent aside, let's get back to this. 2 sine squared times cosine. Okay, what's nice now is that we all have the same argument, which is nice, but I have 2 different trig functions, which makes life, again, a hassle. But what we've noticed, hopefully, is that, well, hang on, I have 2 sine squared times cosine, and that equals cosine on the right side. So couldn't I just divide both sides by cosine? And yeah, if I divide both sides by cosine of theta, divide both sides by cosine of theta, try to be really clear here, I can just cancel them out like such. And we write down 2 sine squared is equal to 1, and therefore sine squared is going to be equal to 1/2. Okay. Now we're good, because now I can just solve this kind of like a regular old equation. So if sine is like my x, then I have x squared is equal to 1/2. I'll take the square root of both sides. So sine of theta is equal to either 1 over root 2. And let's actually rationalize that. So that's going to be root 2 over 2. So maybe it's a little more recognizable. But again, it could be negative as well. Let's just clean this all up. Root 2 over 2. Or sine of theta could be equal to negative square root of 2 over 2. Let's actually make this in red. I just like to color code them on here because, oh, that doesn't just magically change the color anymore, huh? Because it just helps me keep things organized. Okie doke. That's all step 1. Fantastic. Okay, now let's move on to phase 2 or step 2, and maybe we'll do this in green. Let's go darker green. Sorry about that. Let's go darker green. Yeah. All right, so step 2. Maybe I shouldn't have put the line down there, but whatever. All right, so we'll just focus on one of them, and then I'm going to just kind of assume that you'll be able to get the second one and kind of maybe fast forward that part. But we're looking at this guy right here. So I want to figure out what the angle is that makes sine of theta equal to root 2 over 2. This is a recognizable sine value, hopefully. And we recognize that this is going to have to be root 2 over 2 could be right here. Root 2 over 2. So the angle that gets you there is going to be 45 degrees, or pi over 4. The other option, I'm kind of a little crowded here. The other option is to go over here and go to 3 pi over 4, or 135 degrees. Okay, so from here, I can say that sine of theta, not sine of theta, theta itself is equal to pi over 4. Again, and then every revolution there afterwards. So again, pi over 4 will be right here, or back to this, or back to it again, plus 2 pi n. Or theta could be equal to 3 pi over 4 plus, again, 2 pi n. Okay, at this point, so that's step A, 2a that is. Solve the equation for theta. In this case, there's no 2 theta or theta minus anything like that, so I don't have to do that in this case. It's already been done, so that's taken care of. Now I do have to do part C. Again, check values of n that keep us within the desired domain. So we are going from 0 to 2 pi, as stated up here. Let me clean up this epsilon here. So that means we just need to plug in values of n. That makes this equal to, somewhere between 0 and 2 pi. I hope it's pretty clear that if I plug in n equals 0, this will work. 0 will be pi over 4, or 0 will give you 3 pi over 4. Those both check out. But if I add 2 pi on top of that, so n equals 1, then you'll have 5 pi over 4, which is outside of 2 pi. And then this will be, I think, 11 pi over 4, which again is going to be too far. So our only values here that are going to work is when n equals 0, not n equals 1, and then same thing for this example, for this part. So our solutions from here are that theta has to be pi over 4 and 3 pi over 4. If you run the exact same scenario over here on the sine of theta equaling negative root 2 over 2, again, that's going to give you angles that are down here. Either that angle or that angle. So this angle, maybe I'll color code these guys. That's going to be 5 pi over 4. Or if I go all the way around to this part, that's going to be, let's see, 5, 6, 7 pi over 4. 7 pi over 4. Okay. Once again, you will also do the plus 2 pi n business. So 5 pi over 4 plus 2 pi n, or theta equals 7 pi over 4 plus 2 pi n. Again, n equals 0 will work, n equals 1 will not, and so our actual final solution set is going to be these 4 values. Okay, so that's step C, but there is still, I kind of shouldn't have done that. That was step C. So now we have to check for extraneous solutions. So in this example, in this process, I had to to check for extraneous or lost solutions, you have to look back to the process that you used in your transforming step 1. So what happened in this example? In this example, the irreversible step that we did was dividing both sides by cosine. Again, your irreversible steps, or steps that introduce extraneous solutions or lose you solutions, are steps that either add in more instances of your variable, like theta, or take them away. So by dividing both sides by cosine of theta, you lost a solution, again, possibly by removing x's. Okay, so how do I work this out? Well, here's the idea. Can I copy this? Let's see if I can save myself a little bit of time here. Paste. Okay, you want to come with me, guy? Nice. Okay, so here's the deal. This was only a legal move, this dividing by cosine. Dividing by cosine of theta is only okay if it's not 0, because I cannot divide by 0. If cosine of theta is not 0. That's the only reason it wouldn't be okay. If cosine of theta was equal to 1/2, then, well, I could divide both sides by 1/2, and that's totally algebraically legal to do. But if cosine of theta is equal to 0, I can't actually do that. But if cosine of theta is 0, then maybe it is a solution. And so by doing this process, we would have lost it. So all we have to really do is check, well, was it a solution in the first place? So I'm asking myself, I have to check if cosine of theta equals 0 gives a solution. Or I say a solution, but gives solutions in the first place. It could be multiple. Hopefully it's pretty clear at this point. So again, this is the equation that we are looking at. That's the actual equation that we were started with. Well, actually, technically, the actual equation we started with was this guy way at the top. But because we didn't do anything irreversible in these first processes, we could just use this formula as well. So I'm just going to use that because that's already what I wrote down. Okay. So if cosine theta is 0, then I will have 2 sine squared of theta times 0 equals 0, which is actually a true statement. So it turns out that the angles that make cosine of theta equal to 0, again, within the window of 0 to 2 pi, will actually be solutions to this equation. So I need to figure out what those angles are. That's not going to take us too long. Cosine of theta is equal to 0 if theta itself is equal to pi over 2 or 3 pi over 2. And so that's our solutions that were lost, or those are the solutions that were lost by dividing by that process. Okay, there are other ways of doing this problem. So a lot of these trig equations have multiple ways of solving them. And depending on the way you're solving them, you may or may not introduce solutions or lose solutions. But whenever you are doing things like dividing both sides by x or theta, or multiplying both sides by theta, you have to check for either solutions you gained accidentally or lost. Okay, so this equation has 6 solutions like that. Okay, these guys, and these guys.